So, hey, welcome everyone. Hope you had a good lunch. Yeah, good lunch. My name is Sandeep. I'm a developer advocate on Google Cloud Platform. You can follow me on Twitter at Sandeep Dinesh. And today I want to talk about not Google Cloud Platform, but HashiCorp Vault instead, and modern secrets management. But before I get started, how many people have seen this page before, or something that looks like it? Few people. So how many people have used Slack? How about that question? OK. So if you've ever used Slack for a open source project or a community forum or something like that, you've probably run into this page. And what it is, it's a way around Slack's limitation of not letting you invite random people. You put in your email address, you click Get My Invite, it pings the Slack API. It's this backdoor API that's not documented anywhere, and it'll send you an email to join the team. So it seems pretty straightforward, but you have to run it yourself in order to have a public Slack channel. And I wanted to host this on Google App Engine, and this is before we had Node.js support on App Engine Standard, so I rewrote the whole thing in PHP, which is a good idea, right? And I was running into some scaling issues once we hit around 7,000 users, and so I said, OK, I'll make some updates. I updated it. Performance was great. I pushed it to GitHub. And then 2 minutes later, I got a ping from a coworker. And I didn't have to even look at that message to know what I did. I had leaked my Slack keys and my recapture keys to GitHub, and I felt like an idiot, right? And almost 15 minutes later, GitGuardian, this is this free service that is running, found that I leaked my keys and sent me an email saying that, hey, you leaked your keys out. So I was like, OK, if this open source company can detect that I leaked my keys out, probably 1,000 hackers have detected this too, right? Wow, that was really fast. And luckily, it wasn't anything big. It was really easy to fix this, but it was kind of a hassle. I got to regenerate keys, update all the code everywhere, change the Git repository, scrub that commit out of there, do a bunch of annoying things. But at the end of the day, this leak wasn't a big deal. But I thought to myself, what if it was a big deal? What if I leaked out my Google Cloud JSON certificate that let anyone spin up resources on my dime? That's not a good thing. It's Bitcoin mine for days, right? How do people handle this? That was my question. And what I thought, it would never happen to me is a quote from me, right, from my mind. I think a lot of people here feel the same way. You hear about people leaking stuff to GitHub all the time, but you're saying, that can never happen to me. I'm too smart for that, right? Unfortunately, maybe you are smarter than me, but it can happen to you too. And so the whole thing is, how can you minimize these kind of things that can compromise your systems and compromise your organizations, right? So it got to me thinking, what tools do we have out there that can help with this? And what I found out was most organization security looks something like this. It's a hard exterior, right, with a nice, gooey, soft interior. And so you can think of it like a firewall or a VPC or something like that. So how many folks are using a VPC on the cloud to protect their resources? So this means basically if it's inside of your VPC, it has access to your stuff, right? Because who can go inside your VPC? Only you can, right? It's perfectly safe. How many people use a VPN to access their corp network? Yeah, a lot of hands come up. Once you're connected to that VPN, you have access to all your stuff, right? Sounds pretty reasonable. Who can get access to your VPN aside from you? The problem with this security model, the hard perimeter or the fortress security model, is that the smallest hole lets you get access to literally everything, right? Maybe your main application, your production environment is super hardened, you're good to go, and then someone launches this little QA test thing that has a bunch of security vulnerabilities. A hacker hacks that, gets into your environment, and now has full access to your VPC, right? And your super hard production database doesn't matter at all because you have full access to it. That's not good, right? So at Google, we have this idea of Beyond Corp. It's more genericized as something called zero trust networks. And so basically, this means that I don't care who you are. You must A, prove to me who you are first. And then B, I will only give you the minimum set of permissions and operations that you can do to get your job done. So just because you're running on my network doesn't mean you get access to everything I can do. You only get access to things that I will let you get access to, right? And so this means that every single application, every single person, both machines and humans, need to first authenticate who they are, and then after they do that, they only get a limited set of operations that they can do to that other system, right? So zero trust networks and Beyond Corp. So this is great. Internally at Google, we have a bunch of tooling and stuff. We've been externalizing some of that, like the cloud identity aware proxy, which lets you kind of get around the VPN. But you need something for applications themselves, right? The whole thing where I leak my Slack keys, I don't want to be able to do that. I don't want my App Engine app to have access to those Slack keys in a config file. That is like, you're trusting it. You're trusting me. I have access to that config file. I can copy paste that config file anywhere I want, and now everyone has access to our Slack, right? Not good. So I got to looking, and HashiCorp's Vault is pretty much the standard tool out there, open source tool, that's used to manage these kind of things, right? A tool for managing secrets. And to my luck, Seth Vargo, who used to work at HashiCorp, joined my team, and I was like, haha, I'm going to ask you a million questions. So I sat down with him for a few hours, and he gave me a fire hose of information. And at the very end, he said, so I'm giving a talk in Oslo at NDC, but I can't make it anymore. I don't want to cancel. Do you want to do it instead? Sure, I said. Sounds like a great way to learn how Vault works. And it was. It forces you to learn a lot of things quickly. So what Vault is it basically allows you to build zero trust networks in your organization. And it does it very, very in a really nice and easy to use way. So quick agenda for the rest of the talk. Basically, I want to show some scenarios on how Vault can help you secure your applications, how to kind of use Vault as an end user, as a machine, and then how to run Vault in a highly available fashion. So let's look at a few scenarios first on how you can use Vault to secure your applications. So let's look at an application that wants to send a SMS to an end user, right? So your app, you might write this like SMS functionality yourself. Sounds like a waste of time to me. In fact, there's a great company in the Expo booth that'll do it for you called Twilio. So you can go talk to them instead, and basically you can just use their API. You send them a bunch of JSON, and they will send the SMS to your end user on your behalf. But there's a little bit of an issue. To send that JSON to Twilio, they want to make sure that it's you sending that message and not some random person on the street, right? So they give you an API key, and you send that API key along with the JSON payload. OK, that sounds great, but again, I don't want to store that API key along with my application. I lose who has access to that. I lose auditability. I lose what happens if that JSON gets sniffed somewhere, and now I've leaked my keys out. That's not a good thing, right? So instead, let's see how Vault can help with that. I can instead talk to Vault as an authenticated user. Vault will return that API key back to me, and then I can send it over to Twilio. So I no longer store that API key along with my app, either in a config file or an environment variable or hard-coded. I don't do that anymore. Instead, Vault manages that secret for me, and I talk to Vault dynamically when I need that API key to use it, right? So this is probably the most well-known use case for Vault. It's using Vault as an encrypted key value store. So let's take a look at how that works in a quick demo. So basically here, I have Vault running in dev mode, so like not how you're supposed to run it in real life. But for a demo, that's pretty good. So what I'm going to do here is, don't mind that step, but I need to do 1 second. So I'm going to connect to my local Vault instance here. Great. And so let's write some data into the key value store and then read it back out. So let me make that a little bigger so folks can read. So basically, Vault has a REST API that you can use. This is the command line client, which basically just wraps that REST API. So Vault key value put, so it's an HTTP verb, put, post, get, things like that. Secret, so that's a secrets engine, right? So secret will be the key value store. And then slash mySecret, so mySecret is the key, and the value is going to be hello. And so you can see that basically it created it it said the version is 1. So if I update that and I say, NDC, so now the version is 2. So it's actually a version key value store in the latest versions of Vault. So now if I want to read that value back out, you can see that it read it back out, my value, NDC. And obviously, this is a table. You can make it into JSON. You can do whatever. It's just the command line client is wrapping it into a nice-to-read human value for me. So that was pretty straightforward. I can read and write from any path, any subpath. I can get permissions to read from certain paths, not read from certain paths, right? So if we go and look back into our slides right here, obviously here, the app should only have permission to read from this location and not write to it, right? So we can do all that kind of cool stuff with Vault. And we'll talk more about how you actually authenticate to Vault later on. OK, so let's look at another scenario that's a little bit more interesting. So when you're running a microservices stack, you have a bunch of different microservices. And some of them don't need all the data that our user sends us. So an end user might send some data to a front-end application. That data might flow through a bunch of microservices in our stack. And then it finally goes to a backend app that actually needs that data to do some sort of work. Now, the front-end app knows it needs that data, so it's probably hardened. There's some PII reviews, security reviews, things like that. So it's a hardened application. And same with the back-end app. We probably are treating the PII correctly. We understand how to harden it and things. But that random microservices in the stack, it is maybe just like a pub sub or a Redis queue or a RabbitMQ, something like that. It doesn't really know what this data is, and it might be vulnerable to attack, right? So if I attack that random microservice in the middle of our stack, maybe as an internal user, right? You have a disgruntled employee who has access to that thing, and it's like a low priority thing, so you haven't really secured it that well. Well, now they have access to all that hardened data that's flowing into it, right? So what we really want to do is encrypt the data that's going downstream, and then once you go to the back end, we actually decrypt it, right? So this app right here needs to decrypt that data that's been encrypted in this front end. So we can actually use Vault to do this as well. So the front-end app can send the plain text to Vault and get back encrypted data, send that encrypted data downstream, and then the back end can send that encrypted data to Vault and get back the plain text. So the really cool thing here is that this back-end app, you can give it only permission to decrypt data, and this front-end app, you can give it only permission to encrypt data. So that means if our front-end app is compromised, all the previous messages are not readable, right? Because it only has permission to encrypt new data. And if our backend app is compromised, it can't trick our system into thinking there's more data than is really is there. It can't add any new data in. So this is basically using Vault as an encryption service, and the Vault docs call it the transit engine. So let's take a look at how this works. OK, so OK, so basically, because it is encrypting arbitrary data, you need to base64 encode this stuff. Let's clear it out. So I'm going to make it a little smaller so I can read it. So I'm going to say base64 and put some quotes. Cool. So this is the base64 representation of hello. So I'm going to take that in. Actually, let's make something more interesting than hello. Hello, NDC, sure. Great. So you can see there. Who can read base64 just by looking at it? No, I was kidding. I'm sure someone out there can. So now I'm going to say, I love make, by the way. It's great for demos. I don't know how to remember stuff. And then I'm going to say data equals this. OK. So what it did is it basically Vault write into this transit. Again, so transit is the encryption as a service. And then encrypt is the endpoint for encrypting data. And then I basically gave it the plain text equals that. And it gave me back the ciphertext of Vault version 1, blah, 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 right? So if I take this string, and first let's make decrypt data, and let's give it in our string that it gave us. it gives us back the base64 encoded original data that's deciphered, right? And you can see here, basically, I sent it to vault, write, transit again, but instead of encrypt, it's decrypt, and I give it a ciphertext instead of a plain text, right? And so with that, we can encrypt and decrypt data in different portions of our microservices stack without even knowing the encryption key and things like that, right? Vault manages all that for us, and instead, we can just use it as a service. So no matter where in your stack you're encrypting and decrypting data, as long as you see that my key is what's being used to encrypt and decrypt this, so as long as you agree on which basically key, right, so my dash key, you have permission and you use the same key in your front end and back end, you can encrypt and decrypt this data without having to do any sort of pre-shared keys or public key authentication or anything complicated. Just use Vault, which is really nice. OK. So let's go on to the last, and I think the most interesting use for Vault. So how many folks here run a production database in their company? I'm assuming everyone here has a production database, right? How many folks have a QA or staging database that they interact with? Most people, right? For your QA and staging databases, how do you get user accounts? Do you talk to an IT person or an ops person and say, I need a user account, and then they email you one? How many people do that? Few people, right? How many people open up a Jira ticket and then wait 2 weeks and then finally get their username and password? Yeah, OK, I see some hands going up. The problem with this is once you wait those 2 weeks and you get your username and password, you're never, ever, 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 ever going to throw those away, right? You're going to put that into your Dropbox or Google Drive and keep it forever and ever, because the next time you need it for your next project, you don't want to go through that hassle of like doing this whole pinging people, I need another username and password all over again, right? And so this creates something called secret sprawl, where you created this account for this original purpose, and that one account is now being used for 1,000 different things because I want to get my job done and go home on Friday, right? I don't want to just like sit here and wait for a password to come in so I can't do anything. I'm blocked. But obviously, this causes problems. What if that person who has that username and password leaves the company and they put that username and password on their personal Dropbox, and then they get hacked, completely unrelated to you as a company, right? They get phished. And now they have your test password. Oh, it's just my test password. Your test accounts can give so much information away on how your production runs that now they have more information that can attack your production environment, right? They can maybe access your GitHub repository. Maybe they can do all this kind of crazy stuff because you just emailed this username password, right? So instead, and also in this scenario, we have these 3 apps, the admin app, the user app, the analytics app. They all need different sets of permissions, right? So maybe the admin app needs full read access to your thing. The user app has write access to a few tables, read access to some other tables, and your analytics app has only read-only access. So now you need a minimum of 3 different users in your database. So now it's 3 times the chance of one of these getting leaked out. Obviously, your QA and test and all these different environments have different username and passwords. So now your users have to manage where these are in config files and things like that. Gets kind of annoying. But how can Vault help with this, basically, right? So instead of giving your admin app, your user app, your analytics app its own username and password, the admin app actually talks to Vault and says, hey, I am the admin app. Can you give me back a database credential? And Vault will actually talk to the production database or whatever database, create a user on the fly, and then return that user back to the admin app. And now that admin app can use that to access the production database. But here's a really cool thing. Because it's creating that user on the fly, we can actually set something called a TTL on that account. So we can say, if you don't renew the lease within 30 minutes, this account gets destroyed. And even if you're renewing the lease every 30 minutes, after 24 hours, it gets destroyed. So what this means is if you leak a username password that's being actively used, the maximum lifespan it can have is 24 hours. Once that 24 hours is up, that account is no longer useful, right? So they had to rehack your system to get another username password. And if they hack a username password, you detect that it's been leaked, and you don't renew that lease in 30 minutes, it's going to be useless as well, right? So that's really powerful, because even if this account gets copy-pasted into a file, doesn't matter. Within 24 hours, it's gone. And obviously, these numbers are configurable to whatever your organization needs. But this really means that you limit the secret sprawl in your organization. It doesn't matter if someone copy-pastes this into a text file and sends it out. Within an X amount of time that you can guarantee, this account is now useless. And the really cool thing about Vault is it's not just limited to like databases. So obviously you have things like Cassandra and MySQL, MongoDB, things like that. But you can also create cloud service accounts using Vault. So Google Cloud, AWS, Azure, all of these systems actually integrate with Vault. And you can actually create service accounts that can, say, spin up a VM or create a database or whatever. And these accounts only are short-term temporary things as well. So what this means is, let's say your application needs to spin up a few VMs to crunch some numbers and then spin back down. Your application can say, hey, Vault, can you give me a IAM or a service account that can do this? It'll say, here you go. It'll only be active for 30 minutes. Once it's done, I'm done, right? I don't really need it for more than a few seconds, so I don't need a permanent account. And so what this means is even if my app is compromised and someone steals that service account, it'll only work for a limited amount of time, and no one can Bitcoin mine on my dime forever, right? Because that's never happened before. It's happened a lot. OK. So let's take a look at this, what we call Vault Dynamic Secrets. So here, hopefully, I have my MySQL database running. So let's just log into it as root, just to show you that it's working. MySQL H 7.0.0.1 you root. The password is very secure. It's PASSWORD. Boom. OK, we're in. We're into our MySQL as a root user, right? So this is just how maybe you would hard code these username passwords in, just to show you kind of works. So I can say use world. I have like a dummy data set in here. Select star from. Cool. So I basically have all the big cities in the world in this database. This is great. OK, cool. So let's exit this. So that was the root user. And as the root user, actually, let's go back in. I can do silly things like, let's make a new city. Oh. All right, hold on. Let's make a new city called Sandeep's Cool City. That's in the district of Oslo. The population 1, because I'm the only one who can live in Sandeep's Cool City. And obviously, it does not like this. I'm not going to work. MySQL, screw you. OK, so I can insert that in. It works. It worked. Wow, you compromised the database. Thank you, thank you. I'm such a hacker. So I don't want anyone to have root access to my database. So let's actually talk to Vault and use it to dynamically generate some certificates for this thing. So let's get deep creds. Oh, not yet. Hold on. I got to create. Went too fast. OK, so the first thing we need to do is basically tell Vault how to create new users, right? And so it's a little bit hard to read, but basically I create a new role called read only. And so what that is it'll basically run this SQL statement. So create user name, blah, 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 password, grant select on, everything to name at whatever, right? And then I give a TTL max of 1 minute and 1 minute. So and after 1 minute, this account will be useless. So basically, I can create any random SQL statement that will give me any sort of permission to create that user, right? And so now I have this read-only role. Now I can actually run this get db creds, and it'll give me a dynamically generated username and password. So now if I log in to the database, so the user is this thing, and we have 1 minute before this account is deactivated, so gotta go fast. And the password is this. So again, I've logged in, and I can SELECT star. Oh man. So much pressure. OK, so I can select star, but if I try to insert, oh man, I'm going to run out of time. 1 minute was too little. So let's go here, make MySQL write. OK. Hopefully this copy paste will work this time. Oh, it didn't work. OK. Well, OK. Well, let's just pretend again that didn't work because it's a read-only user. But now, if I actually try to log in, I know it's the quote and the S, right? Yeah. I was too cool for my password or for my SQL statement. So let's scroll back up. Ooh, where is it? Right here. So it's been a minute, basically. Where is it? Who can see it? Oh, no, it's after this. The problem is I can't regenerate it because it's already been used. Oh, there it is. OK, here's the password. OK, so now if I try to use this password, it'll say access denied, right? And so even though that worked a minute ago, we've now basically removed that user from our database dynamically. And so this means that even if someone got that username and password, once that time limit is up, it's basically a useless account. And so this is the same thing for any cloud account, any database, anything that has a plugin for Vault that has a dynamic secret backend, right? And so the cool thing about Vault is a lot of people have written their own dynamic secrets backends, so you can use it for a lot of different systems that Vault doesn't support out of the box. OK. So I think that's one of the coolest parts. It really helps you secure your organization. Basically, you can say, every account that we use in production only lasts for this long. So the worst case scenario is even if all our keys are leaked, they're only going to last for 30 minutes. And one other really cool thing about Vault, before we keep going, is the auditing function, right? So let's say that someone actually gets a way to authenticate to Vault. Every time someone talks to our Vault service, it's logged, right? And all the information about who that client is logged as well. So you can actually start alerting and figuring out, are the requests coming to Vault coming from real applications, right? And so you might think, once someone compromises your login to Vault, well, isn't it the same thing as getting your keys anyway? There's actually a little bit more visibility and auditability into accessing Vault versus, say, getting your Twilio key and just using it from some random service somewhere else, right? You don't really know about that versus Vault you have control and viewability into. OK, so speaking of accounts and logging into Vault, let's talk about how you actually use it, right? Because we didn't animations. We didn't really talk about how this part of it really works, right? I still had to talk to Vault to get that API key back. And if I can't do that securely, well, that's pretty much useless, right? So the first thing to think about are something called policies. So policies are kind of like ACLs. They provide a declarative way to grant or forbid access to certain paths and operations in Vault. Pretty straightforward what they do. So let's say you have 2 policies. These are key values, right? So the first policy says you are allowed to read from secret foo, and the second policy says you're allowed to update things in secret foo. So now you have these 2 policies. You can map those to roles. So let's say we have 3 roles. The first role gets mapped to the second policy, so it can update things in secret foo. The second role can read things from secret foo, and the third role can do both, right? So it has both policies mapped to it. So basically, these are like end-to-end. You can map any policy to any role, and any role to any policy. You mostly map policies to roles. That's how this works. So you create all these policies. You can give them descriptive names, and then you can say this role has this policy. And you can put multiple policies per role, too, which is cool. So what is a role, and kind of how do you authenticate into Vault? So it has all of these. It's a big list. I'll break it down into kind of 2 sections, right? So you have auth methods for humans. So this is how a human would authenticate into Vault. So you have things like username, password, makes sense. GitHub username, GitHub login, LDAP. I don't know what Okta and Radius are. I'm sure there are people in this audience who do. But again, it's an authentication server, or a way to authenticate to Vault as a human being, right? And For machines, I feel it's a little bit more interesting. You can authenticate to Vault using things like TLS certificates or tokens. The tokens are actually what Vault uses under the covers for everything. But it's hard to kind of generate that token by yourself, which is why they have these other methods. You can use the app role, which is kind of Vault's native authentication method, but obviously that's kind of tricky to use. So you can also use the cloud provider IAM accounts, as well as Kubernetes service accounts as well, which is really cool. If you're running Kubernetes, it can, Seth actually just wrote and open source something like yesterday that lets you put a sidecar into your Kubernetes pod and automatically authenticate to Vault using the service account built into Kubernetes. So one question that I had, that you might have right now, is you just told me that Vault can generate cloud service accounts, and now you also told me that you can authenticate to Vault using cloud service accounts. So I can use a cloud service account to create a cloud service account. I heard you like cloud service accounts, so I put service accounts in your service accounts. Kind of, sort of. So it's actually better to use it this way than, say, create a service account directly and use it in your code. So let's say, again, you have a service account that can spin up some VMs. Your application needs to spin up VMs to do its job. Now, if you just created that service account and then embedded it into your code, let's say it's a JSON file or whatever, if that JSON file gets leaked, again, anyone who has that can create as many VMs under your billing account that they want, right? But if you create a service account that has 0 permissions and is only used to authenticate to Vault, and then Vault gives you back a temporary service account that has the permissions you need to actually do your job, what this lets you do is, if that 0 permission service account is stolen, well, they can't really do anything with that aside from authenticate to Vault. Once they authenticate to Vault, which they have to break into your VPC to do, right? Once they do that, they have to, it'll be logged and audited, and you'll be like, what is this thing? You're not supposed to be using this service account, only that app is. And then you can just turn that off in your Vault, and then boom, you're done, right? Even if they're able to do 1 or 2 requests and get your service account that's only temporary, they can only spin up so much before you detect that and turn them off, right? Versus like secretly run thousands of machines forever because they keep spinning them up. So even this way, you kind of limit your surface area for attack. You're limiting the scopes of what your accounts are embedded with to just have auth and not have permissions. The permissions all come from the policies and things like that from Vault. You're just using the cloud providers to provide authentication instead of the actual permissions themselves, which is cool. So in a nutshell, basically, auth methods map one-to-one to a role, and then roles map end-to-end to policies. So you can have this role have multiple policies. You can have multiple policies for multiple roles, but each auth method basically maps to a specific role, right? Which makes it really straightforward. Like when you log in as a human, you are on the ops team, so you get this specific role, human on ops team, and that has a certain amount of policies. When your app logs in, it has a specific service account. It logs into Vault. It has a special role, front-end app, and front-end app has a certain amount of policies. Pretty straightforward. OK, last section, running Vault. So there's a lot of ways to run Vault. I'm going to focus on the Google Cloud portion of it, but it's pretty similar in most setups, on-prem, in the cloud, whatever, right? So you basically need 3 different things to run Vault. You need a storage backend that's highly available. You need a way to run your Vault instances themselves that's highly available. And you need some sort of master key management policy or way to do that. And I'll talk about that in a second, because it's a little bit complicated. So for your storage backend, you can use something like Google Cloud Storage. You can also use something like S3 or Azure Blob Store. Basically, you need a storage backend that you can read and write from. And so Vault will actually do the encryption before writing into any backend. So for example, Google Cloud Storage encrypts all data at rest, but it's Google encrypting it, right? So if you don't trust Google, you can use Vault to encrypt it using your own key. So again, any sort of storage backend that's highly available will work. Google Cloud Storage, S3, all these things don't have really great latency and performance compared to a database. But when you're using Vault, you're not really using it like Redis, right? When you're using the key value for Vault, you're not reading and writing super fast. You're like, what is the key? OK, cool, I'll use it. Bye, thank you. You're not doing a million operations per second, right? So something like Google Cloud Storage is probably more than enough performance for everyone here. But if you do need more, you can run things like Google Cloud Spanner or Aurora or things like that to give you a more high-performance backend. But you do pay a little bit extra for that kind of stuff. Now, when it comes to actually running Vault itself, what I would recommend is running it in something like Kubernetes. And so the reason why I would recommend this is because it has to be highly available, right? If your Vault service goes down, remember, let's say you're logging into your database. Well, that key has to be refreshed every 30 minutes. And if it's not refreshed every 30 minutes, even the worst case scenario, you're only going to have 24 hours before that key is gone, right? So if your Vault instance is down for more than 24 hours, all of a sudden you lose production access to your database. So Vault has to be up all the time, right? So I recommend running it something like Google Kubernetes Engine using like the regional cluster, so it's like highly available over multiple regions. Sorry, over multiple zones in a region. And then you're running it in containers, so even if one goes down, Kubernetes will detect that, bring another one back up to take its place. So you always have Vault running, which is a peace of mind, in my opinion. And I'll show you a link for that in a second on how you can actually run that in a secure way. Now, the last part is the master key management. So this is where it gets a little bit complicated, especially on how Vault works. So how many people have gone to a bank to like get a safety deposit box or put something in a safety deposit box? 3 people, right? Usually you go there, and then the bank person and you both have a key, and you put it in and you turn it at the same time, right? And it opens that box up. How many people have launched a nuclear weapon? No, I'm just kidding. It's the same thing, right? You don't want one person to be compromised to compromise your whole system. And so Vault has that same principle where you can basically create a key that's broken up into multiple smaller keys. And so you can break it up into X number of keys, and you can say, I need Y number of keys to actually unlock the Vault. So when Vault boots up for the first time, it's sealed. So before you can use it, you have to unseal it. And so basically this means that you have to take those Y number of keys and punch them all in, and then Vault will unseal, right? So let's say you have 10 keys, 10 master keys. You give them to all the executives in your company. You need at least 4 keys to unlock your Vault. What this means is, like, if you reboot it or anything, you have to basically unlock it again. And so this is like a security measure to prevent people from, like, oh, I just reboot Vault with this like convenient security bug, and all of a sudden, everything's compromised, right? So if you ever restart the Vault process, you have to unlock it or unseal it. That can be really annoying in an automated environment when something like Kubernetes, which is like turning on and like running these containers and killing them and running them somewhere else, if every time a container dies, you have to go and unseal it, right? Ping your CIO and be like, hey, I know you're on vacation, but can you come unseal Vault? Yeah, it's going to get annoying quickly. So I've heard that most people use some sort of automated way to unseal it. And even if you're doing it automated, you can still take a little bit more security precautions. For example, you can use something like Google KMS, or again, Azure and Amazon have their own KMS systems, or key management systems, where the cloud provider will actually generate and rotate these keys for you, and you can use that key to unlock Vault. So this way you have an API and a way to authenticate to Google KMS, get the key, and then unlock Vault when it boots up, right? Again, this is a choice you have to make in your organization. Do you want to automate this away, or do you want to, have a human being go there and unlock it, verify that everything is OK before you unlock the Vault? It's a choice you have to make. I think most people go for the more automated thing, but it is a security trade-off that you have to make. OK, so finally, if you want to know how to run a highly available Vault backend on Kubernetes, Seth, again, just open source this really cool workshop, vault-kubernetes/workshop. And then the second GitHub link is a bunch of Terraform scripts to basically just spin this up on a GKE cluster automatically. If you don't know what Terraform is, it's like CloudFormation or Deployment Manager, things like that, to spin up resources, Chef, Puppet, similar to those kind of things. So that's really cool if you just want it to get up and running. And so the way that those actually work is it creates a separate Google Cloud project. So a project is like I use the word container, but it's not like the container you think about like Docker. Like a box. It's like an isolated box. And what it does is it creates one account in that box, and then it sets up all the Vault and everything like that, and then exposes that over. You can expose that over like a shared VPC or something. So basically, no one has permission to touch the Kubernetes cluster that Vault is running in. It's running in its own isolated Kubernetes cluster, isolated project, isolated everything, and it has just like a pipe to your actual project that's running your actual resources. So this means that even if your project is compromised, they can't compromise Vault, right? So it's just another layer of security. So this is like super secure best practices way of running Vault on Kubernetes. And then if you are using Kubernetes, I mostly talk about Kubernetes, which is why I'm talking about it so much. I love Kubernetes. Again, Seth, yesterday, just open sourced, and we worked on this together, a Kubernetes authenticator for Vault, right? So remember I talked about how you can use Kubernetes service accounts to talk to Vault to get all this stuff. This is basically a sidecar that just does it all for you automatically, and then just puts it into your container using a shared volume. So you don't have to actually worry about Kubernetes service accounts and all this complicated crap. So, and yeah, there's also a tutorial on our docs, which you can read if you want. But yeah, follow us on Twitter. It's fun. Ask me any questions. I don't know if I have all the answers, but I'm happy to try. And also, we have a conference at Next in San Francisco if anyone wants to come. It's cool, I guess. I will be there talking about Kubernetes and things like that. A bunch of Googlers, a bunch of partners. So if you're in the city and you want to go to this conference, talk to me, and I will show you how to buy a ticket. All right, thank you all so much. If anyone has questions, you can feel free to ask me too. And not the survey, whatever, the feedback. They want you to do feedback. So yes, please do feedback. Thank you.